All right, let's jump right in. What if the biggest puzzles in science, things like infinity or the beginning of time, what if they aren't actually problems with the universe at all? What if they're problems with us, with the way we think? Today, we're going to look at a framework that completely flips the script on how we see reality itself. So, let's kick things off with this central question. Imagine if all those mind-bending paradoxes, infinity, singularities, all those logical knots, what if they aren't real features of the universe? What if they're just bugs, glitches in our own mental software? Maybe reality itself is perfectly logical, perfectly consistent, and we've just been reading the wrong user manual this whole time.
To really get what that means, we've got to start in a place where logic seems to completely shatter our understanding of the world around us.
Yeah, you heard that right. Let's travel back more than 2,000 years to an ancient Greek thinker, Zeno. He came up with a paradox so slick, so seemingly logical, that it's been tripping up philosophers for centuries. He argued that something as simple as walking across a room is actually impossible.
Okay, so here's how the argument goes, and it's a real brain twister. To get anywhere, right, you have to get halfway there first. Makes sense. But wait, before you can get halfway, you have to travel a quarter of the way, and before that, an eighth, a 16th, and you can see where this is going. It goes on, forever. Zeno's logic seems to trap us. It says that to make any journey at all, you have to first complete an infinite number of smaller journeys. And that just sounds impossible, right? How can you possibly finish an infinite to-do list in a finite amount of time?
And yet, here we are. We move, we walk, we drive, we fly. So clearly something's got to be wrong with the logic. The framework we're digging into today, the finite infinity, says the problem was never with reality, but with how Zeno was thinking about it. And it solves this by neatly sorting our understanding into 4 different domains. Now, the core idea, the central hypothesis of this framework is this: reality itself has no paradoxes. None. Zero. A paradox, it says, is basically just a warning light on your mental dashboard. It's a signal telling you that your map of the world is incomplete, or that you're mixing up your categories. So let's start with domain number 1, reality. The big one. The best way to think about this is like the actual territory that you'd see on a map. It's the ground truth. And this framework makes a bold claim. Reality is finite. It doesn't do infinity. It had a beginning, and everything is made of a finite number of pieces. It just is. No contradictions allowed. Next up, we have physics. This is our map of the territory. It's our best shot at describing and predicting what reality is going to do next. But, and this is absolutely crucial, the map is not the territory. So if our theories, our maps, start predicting something like an infinity, say a singularity at the center of a black hole, it doesn't mean reality is actually infinite there. It just means our map has run out of road. Domain number 3 is mathematics. This is the language we use to write our map. Now, unlike reality, math is totally limitless. It's a playground for our minds where we can play with concepts like infinity, extra dimensions, literally anything we can dream up. It's this incredible toolbox that can describe any possible universe, not just the one we happen to live in. And that brings us to the final domain, concepts. This is the source code for everything else. It's that boundless, creative space in our minds where imagination is born. It's where the very ideas of numbers, of logic, of math itself come from. This domain has absolutely, positively no limits. Okay, so we've got our toolkit: reality, physics, math, and concepts. Now let's take this new lens and see how it completely demolishes Zeno's 2,000-year-old problem. This is where it all clicks into place. You can see exactly where Zeno went wrong. First off, he ignored reality. I mean, just look around. Things move. That's the ground truth. He also ignored physics, which describes motion with simple finite equations. But his biggest error, his critical mistake, was confusing the domains. He took an idea from the world of math, that you can infinitely divide a line, and he treated it like it was an infinite number of physical tasks you had to complete. But here's the beautiful part. Math, the very language that created the confusion, also provides the elegant solution. An infinite series can in fact add up to a simple finite number. The paradox was never out there in the world. It was a bug in the conceptual software. Now, you might be thinking, okay, Zeno's paradox is a neat little philosophical puzzle, but it's actually a miniature version of one of the biggest, most profound paradoxes in all of cosmology, the problem of infinite regress. You see, if every single effect has a cause, then what caused the universe to begin? And what caused that? It's the exact same logical trap, just scaled up to the size of the entire cosmos. And this is a seriously deep problem. If that chain of causes just goes back forever and ever, an infinite chain into the past, then an infinite amount of time would have had to pass just to get to right now. The universe would be stuck in a state of forever getting started, but never actually arriving.
So, how does our new four-domain framework deal with a paradox of this cosmic scale? Well, this is where things get really, really cool. Applying the same exact logic reveals a totally new and, frankly, stunning picture of our universe. The solution is incredibly simple, but so powerful. If we stick to our rule that reality is finite, then an infinite chain of past causes just isn't possible. It can't happen. The chain must have a beginning. And the sources for this framework describe that beginning not as some chaotic explosion, but as a state of perfect order, what physicists call zero entropy, a timeless state of pure potential, right before the clock of the universe started ticking.
This leads to an absolutely beautiful symmetry. The physical universe, we know, is on a one-way trip from that initial state of perfect order, or low entropy, towards more and more disorder. That's the arrow of time. But then there's consciousness, the thing that somehow emerged from all this, and it does the exact opposite. It takes in all the messy, chaotic, disordered data from the world and creates perfect conceptual order. We have a word for that. We call it meaning.
And what does that conceptual order look like? The sources call it a zero-entropy network. Think about our highest ideals, our most perfect abstract concepts, things like justice, mercy, dignity, love. These aren't just fuzzy feelings. In this framework, they are attempts to build perfectly consistent, perfectly ordered principles out of the chaos of existence. They represent a fundamental drive toward a universe of pure, ordered meaning. So what we have is a universe that starts as perfect physical order. And then, through us, through consciousness, it works to create perfect conceptual order. Now let's see how this incredible, grand idea actually has concrete, real-world implications we can test.
And here's what makes this so powerful. This isn't just some neat philosophical story. No, this model for how the universe began, this idea of a quench from a perfect, timeless state, it makes real, specific, testable predictions. We're talking about looking for unique fingerprints in the cosmic microwave background, that echo of the Big Bang, or searching for very specific kinds of primordial gravitational waves. These are actual signals our telescopes can go hunting for right now, and that's what lifts this whole idea from the world of philosophy and drops it right into the lap of science.
And beyond just physics, this framework has massive implications. For philosophy, it finally gives us a clean way to separate what is from what we know about what is. And for something really cutting edge, like artificial intelligence, it could be a blueprint for a new kind of mind, an AGI built with a core reality model that has to stay finite and consistent, bolted to a limitless conceptual engine for all its creativity and abstract thought.
You see, when we solve these old paradoxes, we don't just finish the journey. We just arrive at a new, more interesting frontier with a whole new set of questions. Untangling Zeno's paradox about motion eventually led us to ask what space and time even are. This framework is a tool for navigating that edge of knowledge. So, what's the next great puzzle out there that's just a simple confusion of domains waiting for us to figure it out?
Because at the end of the day, that's what this is all about. The entire history of science, of philosophy, of human thought is this one incredible, noble process. We use the limitless, infinite power of our minds to draw better and better maps, not to change the territory, but to finally see it clearly for what it actually is: finite, consistent, and ultimately knowable.